Okay, whoops, close that. A little more with normal distributions. Now, we talked about this rule of thumb that it really all comes down to standard deviations and so forth. So, actually what we can do is we can study the normal 0-1 distribution, because if we understand it, actually we understand all of them. So the normal 0-1, and what that means is mu is 0 and sigma, or the standard deviation or standard error, is 1. And so if we can evaluate this one, we can evaluate any of them. And so our textbook, okay, our textbook has tables to help us, and spreadsheets and calculators. Can help us. Okay, so we'll first look at the table, because I think everybody should just see this, but I'll also do a separate video on using spreadsheets, calculators, that kind of thing, to look these things up. And so in our table, in the back of the book, it's Appendix C. You go down, and what it does is it says, okay, it has one table for negative, and it shows this sort of picture, and it says negative Z. And what this picture is doing is telling you what the table gives you. And so what the table gives you is this area to the left of that line, or whatever our value of Z is. So what I know is that's at 0, the middle is at 0, and then these are some numbers of standard deviations. Could be fractional numbers, so we looked at, in the rule of thumb, 1, 2, and 3, but well, I could have half a standard deviation or a quarter or whatever. So the Z value is just that spot on the number line, and so this is saying negative Z. Well, it's to the left of 0 where they put the picture, the shaded area and so forth. So yes, it's negative. And the way the table works is simply, it says over here at the right Z, and it has 0.09, 0.08, 0.07, all the way down here to 0.01, and then 0. And then down below the Z, it has negative 3.4, negative 3.3, and it just keeps going by tenths down here. You know, negative 1.4, negative 1.3, and keeps going, and you know, finally gets to negative 0.3, negative 0.2, negative 0.1, and 0. Now, then inside the table are just a bunch of numbers, and it's got some lines to help us find things and so forth. Here's the end of the table. Now, if I go over from negative 1.4 over to this next to last column here, so I come looking down here, what I see is the number 0.0694, and what that is telling me is that if I'm here at negative 1.48, then this area over here is 0.0694, okay, out of 1, right? It's the proportion of the total population. So it's telling me that about nearly 7% of the full population is over here at negative 1.48 and to the left. Now, what that also tells me is then what's left up here is 1 minus, or 100% minus that, so 0.0694, and so that's what, 0.9306, I think. So that tells me that that much is to the right, but the table itself always just gives me how much area is to the left. And that's the table. That's how it works, is you give me a value of z, and I can, at least to to these 2 decimal places, and I can go in here and I take the first part, the negative 1.4, and then the 0.08, and I put those 2 things together, and whatever number I come to, that is how much of the population, what proportion of the population is to the left of that number. Now, for the positive z, I'll probably need to go to a second page. For the positive z, works the same way. The table is sort of, because it's positive numbers, the table is sort of switched, but again though, we've got this z and it's got this picture, and so the table, we have z, and under that 0.01, 0.1, dot, 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 1.2, 1.3, keep going, and it goes down to 3.4. And then similarly out this side we have our 0.00, 0.01, 0.02, all the way out to our 0.09. And so if I wanted to look up this probability, here's 1.32, and I wanted to know how much of what proportion of the population is to the left, and it's an area, it's because the area under here is 1. So that proportion is the same as the area. I can come over here and look, and I'd go, oh, okay, here's 1.3, and there's the 0.02 to add to it, and I would look for that number, and it looks like, what did I say, 1.32, and so that is 0.9066. Okay, and I get that number, and so that is that area there, 0.9066. Now, it's interesting, right? Go back here. What did I use? Oops, no, not back there. Go back here. What did I use? I used 148. Now, if I come here and I look up, here's 1.4, and I go over here to the 0.08, and I look there, and I look there. Hopefully, actually, because of the symmetry and so forth, what I think I find, I can check my arithmetic this way, I hope what I find is 0.9306. Okay, so I'm hoping that this then is 0.9306. And let's see, 1, 4, and 8. Yes, it is. You'll have to take my word for it as I'm looking at the table, but yes, it is. Right? Because of the symmetry. So similarly, if I looked up negative 1.32, I should find, let's see, this was 9066, so this over here is 0.0834. So if I looked up negative 1.32, I should get 0.0834. Negative 1.32. Oh, I can't add or subtract. That's 934. Yes, 934. And that's what the table says, 934. So that is the idea of looking things up in the table. Now, what if I needed something like 1.324? Well, it's not in the table, but I could estimate. That would be one way to go, is to estimate using the table that way. Okie doke. And we'll call that good with just, kind of that standard normal. We call it the 0, 1. And using the tables, how we look that up. And if I, as we saw, if I need the area to the right, I can take 1 minus. Oh, I did leave out one thing here, I guess. Do we have room down here? Yes. Okay. So, suppose I want that area. Okay, and maybe this is negative. We'll use negative. They don't have to be negative, but I'll use negative 121 and maybe positive 2.08, something like that. Well, what we do is, since the table gives us just areas to the left, well, what I want to do is find, here's 2.08, that's all of that area. Okay, or that proportion, and I want to subtract off negative 1.21, that proportion. Okay, so I have to look those up. I go to the positive table, I look up 2.08, and it looks to me like 2.08 is 0.9812, so this is 0.9812 minus, let me move it down a little bit, 0.9812 minus, and negative 1.21, so I have to go up to the other table. Negative 1.21 looks to be 1131, so 0.1131, and so I do that subtraction. I get a 1 there, an 8, and right, an 8, yeah, and then 7 minus 1 is 6, and 9 minus 1 is 8. Okay, so I think you get 0.8681. Okay, so we can still use the table even if we need to find proportions of the population in there. So remember 95% was between plus and minus 2 standard deviations. Well, so let's look at that. Here's 2, here's minus 2. And again, as I look at, here's 2, and then minus, pretty nasty looking curve there, but there we go, minus 2. What we get for the minus 2, since I'm right there, is this one is 0.0228, And positive 2 is 0.9772. We do that subtraction, and notice we get 0.95, so there's that 95%, or about 95%, and then a little bit left over, so looks like 44. So the actual amount between two standard deviations, plus and minus two standard deviations, is 95.44%, but we call it usually 95%. Okay. Now, some other things, you know, if you're dealing with a positive number and you look in the table and somehow you get a probability less than 1/2, you're wrong. Okay, right? Because positive numbers have more than half the population, and negative numbers have less than half the population to their left. Okie doke, so that's the table and some examples there.